This video lecture will focus on Biot Savart's law. It is obvious that when a conductor carries current, a magnetic field is generated around the conductor. Biot Savart's law describes the relationship between a current element and the magnetic field it generates. For that, consider a conductor which carries a current of 5 amperes. Here dl is a current element, and we are in the position to determine the value of magnetic field at the point P due to the current element. The line joining the current element and the point P makes an angle theta with the current element. Then the value of magnetic field is directly proportional to I, the length of the current element dl, then sine of the angle theta, and inversely proportional to square of the distance of separation. Now read out this. Consider a point P situated at a distance r from a current element dl of a conductor carrying a current of I amperes. The magnetic field at point P is directly proportional to the current flowing through the conductor, the length of the current element, and the sine of the angle between the current element and the line that connects dl to point P. Additionally, it is inversely proportional to the square of the distance between the current element and point P. Now we have presented the entire things in terms of equation 1. See here, dB is directly proportional to I, dl sin theta, and inversely proportional to r square. To remove the proportionality sign, we have introduced a constant mu naught divided by 4 pi. Here mu naught is our magnetic permeability, and its value is 4 pi into 10 power minus 7 henries per meter. Now we have to present the equation 2 in terms of vector form. For that we have utilized equation 3. To understand more about this, consider the formula A cross B equal to AB sin theta. Vector A cross vector B, which is equal to modulus of vector A, modulus of vector B, and sine of the angle between them. In our case, dl vector cross r cap equal to dl vector modulus, then modulus of r cap into sin theta, but modulus of the unit vector r cap equal to 1, then dl vector cross r cap, which is equal to dl sin theta. Therefore, instead of this dl sin theta, we have used the term vector dl cross r cap. But the value of r cap is vector r by r. Now this term should be replaced by vector r by r. Then dB equal to mu naught I divided by 4 pi dl vector cross r vector divided by r cube. Now we have to talk about condition for maximum field. We know the value of dB. dB equal to mu naught 4 pi I dl sin theta divided by r square. If theta is 90 degree, which means that the angle between the line joining the current element to the point P and the current element is 90 degree, the value of dB is maximum. dB equal to mu naught divided by 4 pi I dl by r square, because sin 90 equal to 1. Under this condition, the line joining the current element and the point P should be exactly perpendicular to the current element. See here the angle is 90 degree. The point P is exactly perpendicular to dl. if theta is 0 degrees, you know that sin 0 equal to 0. Therefore, the magnetic field is also 0. If theta is 0 degrees, the magnetic field at the point P vanishes. This implies that the point P should be exactly parallel to the current element. Suppose the line connecting the current element and the point P is parallel to the current element dl, then the value of dB equal to 0. In this case, the value of magnetic field at the point P due to the current element is 0. Now we have to talk about the relation between electric and magnetic field vectors. Here is a point charge. Around the point charge we have constructed a sphere. All around the sphere the value of electric field is constant. Without this, when a sphere is formed around a point charge, the electric field remains uniform at every point on the surface of the sphere, because the electric field E equal to Q divided by 4 pi epsilon naught R square. Here R value is uniform, R value is same at all the points of the sphere. Therefore, there is no change in the value of electric field. However, in the case of magnetic field generated by a current element, it varies at different locations on the sphere because it depends upon theta. Sin theta is the deciding factor in the case of magnetic field. Therefore, the value of magnetic field is not uniform at all the points of the sphere, whereas the value of electric field is constant at all the points of a sphere.